Objective 7, know how to use MCAT to find change in enthalpy and know what each variable represents. So in the example here, I have you burn a candle in a calorimeter containing 100 milliliters of water. The water is initially 25 degrees Celsius and increases to 58 degrees. The candle weighed 19.52 grams before burning and 19.43 grams after burning. What is the heat value for candle wax in kilojoules per mole, assuming wax is C25H52? So you got a couple things going on here. We're going to use MCAT to find delta H, but we're going to, as we do that, we have to keep in mind that our calorimeter is the one absorbing the heat. So we're going to go ahead and use the values for water for mass and C value, as well as the temperature change. So when I use MCAT initially here, I am finding the change of heat for water. And then I'm going to assume because the change of heat for water was created by the heat being released by the candle, that the heat loss of the candle is equal to the heat gain of the water. So I got my stuff here. So if I do that, my M value for water is going to be 100.0 grams because 1 gram equals 1 milliliter for water only. My C value for water, I've used 4.18. I guess I could put a times in there to keep things separated a little bit. And then my temperature change, I'm going to go ahead and subtract the two values given there. I've got 58 minus 25, so it looks like 33 degrees. And if I go ahead and punch this into my calculator, I've come up with 13,794, and that's going to be joules of energy gained by the water. So I can take that times 1 kilojoule containing 1,000 joules and change it to 13.794 kilojoules. And then I was asked to express it as kilojoules per mole. So now what I have to do is look at the 19.52 grams minus the 19.43 grams, and that will tell me that I burned 0.09 grams of candle wax. And I want to change that to a molar amount, so I have to find out how much 1 mole of candle wax weighs. So 25 carbon plus the 52 hydrogen gives me a molar mass of 352.77, so 0.09 grams is going to be 2.55 times 10 to the minus fourth. Oops. 10 to the minus fourth moles. So now I have my kilojoules, I have my moles, so I can go ahead and take 13.794 kilojoules and divide by the 0.000255 moles, and I come up with 13.794 divided by 0.000255. I'm coming up with 54,094, but I'm just going to round it to 54,000 because I believe that's where my sig figs are. Is I'm limited to 2 from some of my earlier calculations. So 54,000 kilojoules per mole would be the heat of enthalpy for candle wax.